Hi, for this video what I want to do is show you how to run a two-proportion z-test in the TI-84 graphing calculator using the p-value decision rule to make our decision as to whether we should reject or fail to reject the null hypothesis. I am going to go through all of the steps, including the conditions, setting up the null, showing all of the work, and interpreting the decision. So this will be a little bit of a lengthy process. I'm not just going to show you how to run it in the calculator to get the answers because it's important to know the entire process. I do want to say that there are different formulas or different symbols that are used in different textbooks and different conditions used in different textbooks. So always just reference your textbook to make sure that the symbols that I use are the same and also that the conditions are the same. All right, let's get started. In a survey of 250 randomly selected females ages 16 to 24 who have completed high school, 72% were enrolled in college. In a survey of 200 randomly selected males ages 16 to 24 who have completed high school, 64% were enrolled in college. At alpha equals 0.05, can you support the claim that the proportion of females ages 16 to 24 who are enrolled in college is higher than the proportion of males ages 16 to 24 who are enrolled in college? All right, so before I start this, one thing that I find that does help with a two-proportion z-test is to set up a little table that tells us all of the important information that we need for all of the formulas. So before I start this, I would go through and find my important information for both males and females. The first thing that we want to know is our p-hat1. And our p-hat1 is just the proportion of females as a decimal. So I already underlined that, and that was 0.72. We want to know N1, which is our sample size for the females, because N1 and N2 are often different. So for this one, our females, we have 250 females. And the last thing that we need to find is X1. And this is important because we need it in order to find our p-bar is what we call it, but it's the average of the two proportions that we are going to use to run the test. And if you're plugging this into your calculator, you're going to need this as well. So X1 can be found by doing N1 times p-hat1. So I would just take 0.72 times 250, and that gives me 180. If it is not exactly an integer or a whole number, you do need to round to the nearest integer or whole number because we're talking about the number of successes or the number of females who responded yes. So then we're going to do the same thing with the males. So males, the p-hat2 is the proportion of males that responded that they were enrolled, which would be 0.64. And their sample size, if we notice, is 200. So we have a total of 200 males. And our X2, again, to find this one, we would do our N2 times p-hat2. So I would take 0.64 times 200 and I get 128. And again, if these are not whole numbers, then you do have to round them to the nearest whole number because this is a discrete distribution and we cannot have partial males or females that respond. All right, so the conditions that must be met, and like I said, with the conditions, I've looked at many different stats textbooks, and all of them that I've looked at have different conditions in them. So I'm using the ones from the textbook I'm currently teaching from. I advise you to look at your conditions in your textbook to make sure that you have all that you are required to have down. All right, so the first one is that we want to have independent samples. And the males and females who responded are independent of each other. So males and females are independent. All right, the second one that needs to be met is that we have to have some kind of random selection, and it does state that randomly selected all right, and then the last one, in order for this one to be met, we have to find p-bar and q-bar. And like I said, your symbols may be different. In the calculator, it gives it as p-hat. In other technology, sometimes they write it as p hat also. The textbook that I'm currently using uses p bar, which is just putting together the average of the two proportions. So to find p bar, we would do x1 plus x2 over n1 plus n2. And basically what this is going to do is going to allow us to make sure that we've sampled enough people in order for the sampling distribution of the sample means to be able to, the sampling distribution of the sample proportions to kick in, we have to have a large enough sample size. Okay, the textbook that I'm currently working from says that this has to be greater than or equal to 5 when we find our sample sizes times this. Some other textbooks that I have worked with use 10 as the threshold, so again, just look at your textbook. All right, so x1 is 180, x2 is 128, n1 is 250, plus n2 of 200. If you are going to do hand calculations later for z and you're not relying on a calculator, I would advise finding this as an exact fraction. Because I'm plugging it in the TI-84, I'm not going to worry about that because it will give me the answer to z, so I don't have to worry about plugging it in. So when I plug this into my calculator, I get approximately 0.6844. Okay, and q bar, remember, is 1 minus p bar. And when we do this, if I take 1 minus 0.6844, we end up with approximately 0.3156. Okay, so our condition or our threshold to make sure that we have a large enough sample is our n1 times p bar has to be greater than or equal to 5. So I would take n1, which is 250, and I would multiply it by 0.6844, and I end up with, all right, so 250 times 0.6844 gives us approximately 171, which is greater than or equal to 5. Then we would do the same thing for n1 times q bar, and so we would again take the 250 times the 0.3156, and we get approximately 79. Again, that's greater than or equal to 5. And the reason I rounded to the nearest whole number is because of the fact that we're dealing with people again, so our sample size has to be greater than or equal to 5. If I were using the threshold of 10, both of those meet that condition as well. So into p bar, this time we would use 200 times 0.6844, which is approximately 137, which is greater than or equal to 5. And then into q bar, we would take the 200 times 0.3156, and we get approximately 63. So since all of our conditions are met, we can use the two proportion z-test. So if you are asked the name of the test, the name of this test is the two proportion z-test. All right, so our next step is to set up the null and the alternative. And remember that this comes from the claim. So let's go back and look at what the claim says. So the claim tells us that the proportion of females, so that was going to be P1, who are enrolled in college is higher than, so higher than means greater than, the proportion of males, so P2. Okay, so since this is an inequality statement, we would put it in the alternative. So our claim this time is about the alternative, so we would say that P1 is greater than P2, and the null would be that P1 is less than or equal to P2. Okay, some textbooks write it this way instead, where they say P1 minus P2 is less than or equal to 0, and then P1 minus P2 is greater than 0, because we're really testing the difference between the two, and so we're starting with it being 0. Some problems will say that the proportion, they might say that the proportion of females is greater than the proportion of males by a factor of 5%, so then I would change that to 0.05, but most of the time it's going to be 0. Since this is greater than, we always look at the alternative to decide whether we have a left tail, right tail, or a two tail. Since this is greater than, we would have a right tail test. Okay, so that's important for when we go to shade. We do have to shade the right tail. Our alpha level that we are going to be using is 0.05, so I'm going to go ahead and write that down. And like I said, I am using the p-value decision rule. I'm not going to shade it yet because I'm going to run it in my calculator first to help me to decide what proportion I should be shading. But I am going to write down that I'm going to be using the p-value decision rule, because if you're using the rejection region decision rule, your model does change. So the formula for this to find z, our standardized test statistic, is we're going to take p hat 1 minus p hat 2, and then we're going to subtract from that the difference of p1 minus p2. And then we will divide this by p bar, q bar, times 1 over n1 plus 1 over n2. And so in case you're required to show work, I am going to go ahead and plug in those values. So p hat 1, remember we had in the chart is 0.72, p hat 2 is the 0.64, so we would plug in 0.72 minus 0.64. This part right here is going to be 0 because we're really testing the claim that there is, or not, we're not testing the claim, but our null hypothesis, we're assuming that the null is true, and so we assume that the equality statement in here is true, and so it would be equals 0. So the p1 minus p2, the difference is 0 is what we're testing it against. I don't have to write the minus 0 because it's not going to change anything. All right, so p bar, remember that if you were going to plug this into your calculator, it may be best to leave this as a fraction because that's an exact value. We rounded, so it can throw off your z-score, and I know that if you're using online homework platforms, that can throw off your answer enough to where you get the wrong answer. So just be advised that if you do round, I would advise rounding to a minimum of 4 decimal places. Since we're using the calculator to get the answer to z, it doesn't matter that I'm using the rounded. This way it just shows that I can plug in all of the values in the right place. All right, so like I said, we are going to use the calculator to help us find the answer to this z, and then we are also going to find the p-value in the calculator. Remember, the probability, or the p-value, is the probability value, so this is the probability of getting this difference between the two proportions if there really was no difference. Okay, I'm not going to write it down in symbolic form, but that's what the p-value represents. So when we grab our calculator, what we're going to do is we're going to hit stat and tests, and we're going to find the two proportion z-test, which is option 6. And in this, you're going to use the information from our table. That's why I advised setting this up as a table, because it makes it easier to plug it in. So we're going to use that information to plug in. I do have it on paper, so I'm just going to look at my paper. Our x1 was 180. The sample size of our first one is 250. x2 is 128. n2 is 200. And then we want to select the one that matches our alternative, which is greater than. And I am going to draw this in just one second, but I did want to point out that if I calculate this, it does give me my z, which is 1.8145. My p-value is 0.034798. It also gives us our p hat 1 and our p hat 2. And then notice right here, this is our p bar. The calculator gives it as p hat, which is the notation that some textbooks use instead of p bar. So I just wanted to point that out, that that was given to you. So I'm going to go back to the two proportion z-test. Everything is still the same because I haven't changed anything. And I'm going to go down and I'm going to draw this, and then that way I know how much to shade on my picture. So we can see that we don't need to shade very much. The p-value is 0.0348. Okay, so I'm going to go ahead and shade that in here to match. This is my p-value, 0.0348. And this is my z, which was approximately 1.8145. and just round to however many places that your homework tells you to. Typically with p-values, we round to 4 places, and z-scores we typically round to 2. Just make sure that you read the directions, because I know that some homework platforms are very picky. Also, some professors are very picky about rounding to the correct place. All right. So now we need to make our decision, and remember that our decision rule is we are going to compare our p-value to alpha. If the p-value is less than or equal to alpha, we reject. If the p-value is greater than alpha, we fail to reject. So our p-value is 0.0348, and our alpha is 0.05. So with this one, we can see that 0.0348 is less than 0.05. So since it's less than, we reject the null hypothesis. So our findings are that the null hypothesis is not true. We don't know that with certainty. It is possible that we could make an error. But the evidence from our sample, or our 2 samples, points towards the alternative being true. So our last step is to interpret the decision. So we would say at 5%, we always start with our alpha level. And I tend to use the percentage rather than the alpha, just because if I put alphas in there, then nobody understands what I'm talking about. If I put 5%, people kind of at least understand what 5% means. So at 5%, since we rejected, we will use the wording, we have enough evidence. You could also put we have sufficient evidence to, and for this one, because our claim is about the alternative, we are supporting the alternative. So we have enough evidence to support the claim that the proportion of females ages 16 to 24 who are enrolled in college is higher than the proportion of males. Okay, so our evidence points towards the alternative being true, and so since our claim was in the alternative, we are supporting that claim. If we had failed to reject the null, then we would not have enough evidence to support the claim. I know that hypothesis testing can be overwhelming, and I know that there are a lot of steps, and a lot of times we want to just find Z and P to plug it into the homework platform so that we can get our answers, but it's really important to know the entire mechanics, which is why I take the time to go through the whole thing. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you need me to cover, please let me know that as well.